Good morning, boys and girls, and welcome to my kitchen. My name is Harley, and today we're going to be doing some fun kitchen science with a focus on chemistry. So can anybody here tell me what chemistry is? Anybody? Chemistry is basically when you put any sort of things together, solids, liquids, gases, and you get something out of that. It also is a branch of physical science that studies structure, combinations, and properties of matter. So I kind of already mentioned those properties of matter that we have. So if you don't already know those, they are, say it with me, solids, liquids, and gases. So those are the three main ones that we focus. There's also one called plasma, but we don't focus on that one as much just because it's not studied as much. So what we are going to be doing today is we're going to be doing three different experiments. The first one is going to be a focus on something called pH. So I don't know if any of you guys know what pH is. Oh, hold on one moment. Oh no. There we go. Camera almost messed up a little bit there. So pH is something that we use to determine if something is acidic or basic or neutral. So if it was acidic, it would have more of those H plus ions, and if it was basic, it would have more of those OH ions. So something I have right here is something that we use for pH, and it's mainly in the form of a scale. So it's kind of hard to see just because of the glare. But a pH scale, we determine those based off of colors. So when it's super acidic, you're going to see the color of something be a little bit more red, orange, yellow, things like that. And then if it's neutral, it's going to be a little bit more green. And then if it's basic, it's going to be purple, blue. So that right here is our pH scale. So we use that to determine if something is acidic or basic. So, but to do that, not everything is that specific color. Like, you're not gonna look at a lemon, for instance, and be like, oh, I don't know what that is, because it doesn't show you that color. But what we use to determine that is something called a pH indicator. So in the lab, we use things like bromothymol blue. But today, we are going to be using a cabbage. So we are going to be using this red cabbage, which is something that you can get at the grocery store, or you may already have it in your fridge. So we're going to be using this as our indicator today. So there is something in this that will bleed out of this once we boil it, and it's called anthocyanin. So that is a chemical compound that is in red cabbage that will help us create an indicator. So the first thing you're going to be doing is making that indicator. So to do that, you are going to need to get one of these, a big red cabbage. You can see I've already used half of mine over here in the pot. Cut it into as many slices as you want. You can even grate it if you like into one of these graters. And then you're going to put it in a big pot, or whatever size pot you have. I have a nice big pot like this. You're going to put it in a big pot like this, cover all of that cabbage you have up with water, and boil it. I boiled it very heavily and rapidly for about 5 minutes until you are going to be getting this dark purple bluish color. So this right here is our indicator. So you guys may be thinking, though, on that pH scale we saw that blue was basic. That doesn't always mean that it's going to be that, even if it bleeds out that color. So in front of me I have 12 different solids or liquids, whatever you want to use. And we are going to be putting some of this into those and seeing what we can find. So the first one I have is ketchup. Then we're going to do citric acid, cream of tartar, vinegar, baking soda, borax, milk of magnesia, soy sauce, lemon juice, some just plain whole milk yogurt, this household cleaner that I have, and some Castile soap. You can use whatever soap you have, and you can use honestly with any sort of materials you have in your kitchen as well. This is what I had, so this is what I decided to use, just to kind of give you guys a basic of it. So I also have a pipette. You can use a turkey baster, or you can just use a spoon and kind of pour it into each of your bowls. So I kind of have them in different bowls because I didn't have enough of these little guys right here. Keep going. I didn't have enough of these little guys right here, so I kind of had to like use some of these and like a glass and things like that. So what I'm going to do is I'm going to take a nice squirt of this and put it into my ketchup. We're going to keep doing that for all of them and see what we can find. Not noticing anything right here, so we're going to let it sit for a little bit, see. Then this next one we have is citric acid. Maybe we'll see a little bit better color change in this one. Whoa, okay, we definitely did there. What do you guys see? Very pink, right? So on our pH scale, that is going to mean that it is acidic. Dang. You can also see the liquid in this ketchup is also a little bit acidic as well, which makes sense because tomatoes are acidic as well. So then the next one we have, this is the cream of tartar. This is used in baking. So again, you can use whatever you have. Ooh, interesting. Also a little pink, but not as pink as the citric acid. It's definitely a little bit duller than that as well. All right, next one we have is the vinegar. So whenever you're doing this experiment, you can also apply the scientific method to it. So you can propose a hypothesis, do your testing, and then record your results and see if you were wrong. So let's see, ooh, nice and pink too. Getting a lot of acids so far. Hopefully we get a base here soon. What do you guys think? Alrighty, that is our vinegar. Alrighty, next one, baking soda. Here we go. Oh, yay, finally, a base. There we go, wow, that's a pretty color. Very blue. Alright, next one, I have to keep glancing back, borax. Alright, borax is just another kind of cleaner you can have around. Oh, wow. Kind of dull. Looks like it would be a little bit more along the neutral zone, which is probably good. We don't really want acids in our laundry, do we? Next one, milk of magnesia. So milk of magnesia is something that you can use if you have an upset stomach. So your stomach would be super acidic. So to neutralize something that is super acidic, you would want to add a base. So that being said, this should be more on the basic side, and it is. Awesome, that's so cool. Next one, soy sauce? Yes, we got soy sauce. Awesome. These darker colored liquids are a little bit harder to see. But if you were using a really strong chemical pH indicator, you'd probably be able to see it a little bit better. Still kind of looks like soy sauce. Next one, lemon juice. So we're on to our bigger glasses now. We got lemon juice. Ooh, nice and pink. We got another acid, boys and girls. Lemon juice is acidic. Alrighty, and we got whole milk yogurt. Yummy. What? Wow. Kind of pink, huh? I'm gonna pour this in here, see if I can get a little bit better. Oopsies, spillage. Okay, so this is kind of looking more, it's like a purplish pink. So I would almost say that that's probably gonna be a little bit more basic. Alrighty, next one, this Thieves household cleaner. Let's see. It's kind of yellow already. So let's see, but it looks pretty neutral because when I put it onto this white cutting board to kind of get a nice gradient behind it, looks like it's gonna be pretty neutral. That's good. Don't want acidic cleaning products. And then we have the Castile soap. So let's see what this one is as well. Ooh, a pretty color soap. Nice and green, kind of a greenish blue. Wow, this is crazy. So now that you have put your pH indicator, your red cabbage pH indicator, into all of your different cups and bowls, I would recommend that you look at a pH scale like so, and then put them in order from most acidic to most basic. So based off of the ones that I did today, I would gonna have to say that the baking soda was my most basic. Very blue. It's the bluest out of all of them, most basic right here. Then my most acidic, I'm gonna have to say that it's between the citric acid and the vinegar. Like, it's so close, but I think I'm gonna go with the citric acid. So the darker the color is, or the more that it's pushed to either the further left or further right on this scale, that means that it's gonna be either a stronger acid or stronger base. And then if it's more into the middle, like the neutral zone, it's gonna be a weaker acid or a weaker base. So then this one right here, super duper green, this is gonna be in the middle, that neutral zone for sure. So we've got a lot of acids and a lot of bases. So I wish you guys could see all of this, but I don't wanna mess with the camera too much. So that is our first experiment with our pH indicator. So I hope you guys have a fun time doing that. And I'm gonna save this bottom for another kitchen science episode as well. So let's put all that away so that we can get on to our next experiment. And that is going to be including some of these materials that we had right here. And it's also going to be involved with pennies. So let me get this stuff right over here. Alrighty, so I have a bunch of glasses again. I was running out, but you gotta use what you got. Alrighty, so I didn't do 12 this time, but you can do 12 if you want to. I just did 7 different mixtures and solutions so that you guys can see those. Alrighty, so the way this experiment works and what it's about is we are going to be looking into pennies and how to clean pennies with kitchen supplies that you have in your own kitchen. So the reason this is super interesting is because pennies aren't always shiny, and we're going to be hopefully trying to make some of these shiny as well. But if you want to, oh, I already pulled them right here. So this penny right here is already really shiny. So that means that it doesn't have this nasty green color on it, which you basically get from CO2 being exposed to the air, and then you get copper carbonate. So that copper carbonate is what is making this like brown greenish color right here. So there's also other types of metals that make weird colors like this as well. Like silver can turn black, like jewelry. And iron can turn brown, so that would be rust. So that would just be when it's exposed to moist air. And then silver turns black when it's exposed to sulfur in air, so you get silver sulfide. So we are going to be seeing if we can clean a dirty penny like this and make it nice and shiny like this. So mine have already been soaking for a little bit because I wanted to just kind of show you the results. But what you would do is you would put all of your solutions, whatever you decided to use to see what would clean the penny the best, in little cups like this. You don't need that much, just like a little bit like that. So the ones that I did so in this one I did vinegar. So we used that before, and remember that we discovered that it was super acidic. So maybe it will, maybe it won't. This one's just plain water. This one is some salt water. This one's ketchup. This one is some of that dish soap that I had. This is lime juice concentrate. And this is soy sauce. So I've had these resting for about 20-30 minutes. So what you're gonna want to do now is you're gonna wanna take a paper towel. The ketchup one is probably gonna be the grossest for sure. So you're gonna wanna clean them off so you can observe what they look like. Almost all of my pennies, they were around this dirty. You can't really see it too well, but they were pretty dirty. So you're just gonna have to trust me. So we're gonna take them out, look at them, observe what we got. So right here in the, what was this one again? The vinegar kind of looks cleaner than we went in there. Let's get the water out. Nothing changed the water, but I mean, I didn't really expect anything to change that. Dry them off a little. They're wet. Salt water also looks the same, nothing big there. All right, time for the ketchup one. I'm gonna rinse this one off. Oh wow, this one definitely started to clean it well for sure. So it still has some like larger spots on it, but for the most part, it's much cleaner. All right, and then we have the dish soap. Ooh. Dish soap one. Let's see, you can clean anything with dish soap, right? Not that much of a change. Lime juice concentrate. Oh wow, that definitely looks cleaner as well too. But I mean, any sort of citrus is going to be cleaner. Holy cannoli, soy sauce one. Definitely the winner, for sure. Definitely. So the soy sauce was our clear winner in today's experiment when you're trying to determine what can clean the penny the best. So we got soy sauce and then probably the ketchup. But if you're really trying to learn how to clean the pennies the best, I have learned that a little bit of vinegar and I think baking soda you work the best. I'm pretty sure it was those two. Vinegar and salt. So just mix those two together, let them sit for however long and see what you can find. But you can also leave these for a little bit longer if you'd like to see if that makes a difference as well. So that is our second experiment. And the last one for today is something that kind of concludes it all, working with our solids and our liquids, and it is going to involve an apple. So right here, I have a hollowed out apple like this. So we are going to be finalizing this experiment and this video with a gas. We didn't really get to see any gases here today, just some solids and liquids, and determining their if they're acidic or basic. So what I want to do with this and what you are going to be doing is you're going to take an apple. You are going to cut a circle out of it with an adult's help. Kind of hollow it out with the spoon as well, but you got to be careful because you could rip the apple like I did. What you're going to do next is we're going to be mixing 2 of our materials that we used today into this apple and trying to determine what happens. And again, you can use the scientific method with this one as well. So what I'm going to be using today is I'm going to be using a base right here, baking soda, and an acid, which is vinegar. So I'm going to get a spoon, put some of my baking soda into this apple. Use however much you'd like. I would recommend putting this in a bowl or putting it in a tray so that you can see the results. So in here I have the baking soda inside my apple. The next thing I'm going to be doing is I'm going to be cleaning off my spoon and getting some of this vinegar and pouring. That's not going to work though. Let's use this pipette. Sucking up some vinegar and putting it straight into the apple. What do you guys think is going to happen? Let's see. 3, 2, 1. Whoa. We're definitely observing some bubbles, which whenever you see bubbles, that indicates a gas, right? So we mixed our solid, our baking soda, and our liquid, our vinegar, together to make a gas. Whoa. And it just keeps going. That's awesome. Alrighty, boys and girls, so I hope you had a fun time today in the first episode of Kitchen Science with a focus on chemistry. If you have any questions about any of these, or you want to show me your results, just put it in the comments below and I would love to see them. Thank you guys for joining, and always remember, please try to donate to the Science Center if you can. Any amount helps.